We are going to do some linear systems on Desmos today. So first off, I want to make it known that this video is talking about how to solve the problems, but there's a separate video that talks about how to use Desmos and how to actually set these problems up, okay? This one's focused on the math, not the website, but there is a different video if you are curious about that. So we're going to start by looking at this and look at systems of equations. So the whole idea about a system of equations is if we have two lines, or really any number of equations, any number of graphs, the solution is the intersection. Solution is just what makes both of them true. So in general, a line are all the points, every point on a line. So every point on a line, maybe this point, for example, is just an x and a y that make that one equation true. Now, all these red points are just all the points that make that second one true. October, don't lay down on the tablet. No, I'm sorry. Very cute. But no, not right now. Okay, so then the solution to this system, the solution to multiple lines is just the point that makes both of them true. The point that's on both of the lines, that's going to be their intersection. She really is adorable right now. She's kind of sleepy, a little dumb. So the point is, of course, right here. The ordered pair, that's an x coordinate of -4 and a y coordinate of +1. We're going to write -4, +1 as an ordered pair. Explain my thinking. This is the point that is on both lines. So it's a solution to both equations. Share with the class. Done. Great. Next one. Pair each graph with its solution. So we're going to talk about, looking at graphs, looking at solutions. So let's organize things however you want. But remember the solution. I'm going to zoom in here a little bit. Oh, maybe not. The solution is just the intersection. So zoom in. Hopefully you can read this graph. The intersection here is an x coordinate of 6 and a y coordinate of 3. So the solution is 6, 3. We just go look around and find 6, 3. There it is. And we attach it just like so. This next one, these are two parallel lines. Where do they cross? Well, they never cross. There's no point that's on both of them. So we're going to attach no solution. This next one, they cross at an x value of -1 and a y value of -3. So -1, -3. And this last one at an x value of 5, y value of -2. And everything else goes away. Oh, there's more. There's more options. This one is a -4, 1. And this one, whoa. What's going on with this guy? It looks like there's only one graph. But don't worry. That's just because both graphs are the same. It's possible to have two lines that have the same graph. All right, and if for more talking about this, we'll talk about this more actually in the 96 video as well. I got some cat hair in my eye. I don't know how that happened. But if we have something like y is equal to 2x plus 5, and a second equation, 2y equals 4x plus 10, these are actually the same equation. So there's infinitely many solutions. Because notice the blue one is just what happens if you multiply the red one by 2. So in this equation, right, if we graph the red line, if we graph the red line, it's 2x plus 5. Okay, so that's a y-intercept of 5 and a slope of 2. This is what the red line looks like. And then likewise, the blue line has the same slope and the same y-intercept, once we divide everything by 2 and put it in the right form. So we graph it exactly the same. The red line and the blue line are literally the same exact line. So it looks like we're only looking at one. All right, so that's what's happening with this last one. There's infinitely many solutions. It's really the same equation. That's what we're kind of looking at here. All right. Let's look at number 6. So now we're actually going to solve some systems without graphing. And there's a couple of ways of doing this. There's the analytical method. We're gonna not do graphing. So there's the substitution method. And there's the elimination method. So let's look at just one of them. Let's look at this guy to start. Y equals 2x plus 1. And y equals 6 minus 3x. The two different methods, both will always work. Sometimes one will be easier than the other. You can choose whichever one you want to use. The first method, called elimination. And the second method is called substitution. Let's start with substitution here, because this is a perfect opportunity to use the substitution method. To use the substitution method, solve for y. We already solved for y. It's already in solved for y. It's y equals already. Both of them are. We only need for one. Solve for y in one equation. And then plug in that y to the other. To the other. There's a O in that word. So for example here, it doesn't matter which one we look at. Let's look at this first one. Y is equal to 2x plus 1. So if y is equal to 2x plus 1, then we can replace it. Y is 2x plus 1. Equals means they're the same thing, like a magic trick. Same exact thing. Replace the y then. That'll give us that 2x plus 1 equals 6 minus 3x. And now we can solve for x. All right, so now it's just like before. We solved linear equations before. Get all the x's on one side, get everything else on the other side. So we add those 3 x's. And that's going to give us 5x plus 1 equals 6. Now you have to subtract 1 from both sides. We're going to get 5x equals 5. Divide both sides by 5. And we'll get x equals 1. But that's not our answer. It's part of it. It's right. We're just not done. We're looking for the solution to both of these equations. I have the x coordinate, but we still need the y coordinate. So we know that y is 6 minus 3x. We also know that y is 2x plus 1. It actually doesn't matter which one we use here, because the solution will be true for both. So we can use either one, your choice. Y is 2x plus 1. And if x is equal to 1, then replace the x with 1. So y is 2 times 1 plus 1. X is equal to 1, and y is equal to 3. Our answer is the point 1 comma 3. That's the substitution method. Solve for y. In this case, it was already solved for y, but we have talked about how to do so. And then plug that into the other equation. If the other method number 1, doesn't matter what you call it, is called the elimination method. And what's the easiest way to describe this method? I would say it's, you try to add or subtract the equations. Add or subtract the equations from each other. to eliminate, that's where the name comes from, a variable. It doesn't matter which one we eliminate. So notice that if I take the first equation and subtract the second equation, right, if we subtract out the second equation, we get y minus y. That'll eliminate the y variable. Or we could multiply one equation around and get some other stuff. We'll talk about this more in the 96 video as well. Okay. But if we look at, let's say this is I got to be careful with my letters. Say this is equation A and this is equation B. Well, if we take equation A minus equation B, what do we get? Subtract the left-hand sides. Y minus y. Subtract the right-hand side. 2x plus 1 minus 6 minus 3x. We're subtracting that whole right-hand side. So we need parentheses here. And the reason why we can do this is because just the same way as what we did over here, we can add or subtract whatever we want from both sides of an equation as long as they're the same. And notice these two quantities that we're subtracting are the same because y is the same thing as 6 minus 3x. So we are subtracting the same thing from both sides. They look different, but we know they're the same because y is the same thing as 6 minus 3x. That's what equations are all about. And now we can simplify this. We have 1y. We took the 1y away. Now we have 0 y's. Got nothing left. We have to distribute that negative. This becomes a minus 6. Distribute the negative again to plus 3x. Solve this equation. Collect like terms. 2x's, and then we have 3x's more. That's a lot of x's, hopefully not all in the same room. And so now we have 5x's total. And we're subtracting plus 1 minus 6 is a minus 5. So now we can add 5 to both sides. And when we add 5 to both sides, we can get 5 is equal to 5x. Divide both sides by 5. We are going to get 1 is equal to x, which is the same thing as x equals 1. Just like before, we also got x equals 1. We can now plug it into whichever equation we want. Let's use the other equation this time. We can plug in whichever one. So let's plug it into y is equal to 6 minus 3x. Both equations should have the same answer here. If we plug in x equals 1, x is the same thing as 1 in this case. We're going to get that y is 6 minus 3. Y is equal to 3. Hey, that's the same answer we got. So both answers give us an x value of 1 and a y answer of 3. You don't have to use both methods. Sometimes one method will be easier than the other. We'll do more of this in the 96 video. And that's the idea. So our answer for this one is going to be 1, 3. X is equal to 1. And the y value is equal to 3. It doesn't have to be in order, but usually we put things in alphabetical order here. So you're going to do the same thing with these other ones. And again, there will be more of this in the 96 video. Do I want to make one comment on this one? So then there's this one where I'm not going to do this whole next problem, but just to remind you, you can just graph these lines. Like we've done previously, graphing lines, slope-intercept form, rise over run, that sort of thing. And the solution will just be their intersection like we did at the start of this video. So feeling good about systems of equations, that's great. Feeling bad about system of equations, that's fine too. Check out the 96 video for more review on this. All right. Good luck. Bye-bye.